Okay, good afternoon. Today we're going to discuss cameras. So, the first and the simplest camera is a simple pinhole camera. So, you essentially have a box with film on one end of the box, and there is a pinhole right there at the entrance. That's the pinhole, and this is the photographic film, right? And that's it. That's the simplest camera that you can make. So here what is happening is a bundle of rays from the object, that is the arrow here, right, are going through the pinhole. Recall that from Fermat's principle, light goes in straight lines, right? So this light is bundle of rays is going this way, and this is going this way, right? So you would notice that the image is actually inverted on the film. So if you look at this circle here, that is a bundle of rays coming from one point. So this bundle of rays propagates through the pinhole and makes it to the film as another bundle. So what you see as the image here is essentially an overlap of several bundles of rays of light that are coming from different points on the object. Each point on the object is emanating different bundles of rays that are going and hitting the film, leading to the appearance of an image. This is just a cross section of what you have in the pinhole camera. So the pinhole camera looks beautiful. So one would think, why do we need more improvements at all? For starters, you cannot picture any moving objects with the pinhole camera. As you can see, the object needs to be very, very stationary for you to capture a picture. The second thing is everything around, there is no focusing, right? So everything around, if I have somebody here, okay, let's say this is the guy you hate, and you don't want him to be in the picture, but he's just standing right there next to you. You cannot avoid him, and in a pinhole camera, even light from him would simply make it through the pinhole, and you would see all different sorts of images. So in fact, when the pinhole camera was invented, people thought that because from far away objects, light used to be uh, uh, falling on the film from faraway objects like shadows, and people would think that they are the ghosts of their loved ones, right? So, but it was nothing like that. It was just the simple magic of, pinhole. Anyhow, so now the next question is, how can we make this simple pinhole camera better? To make it better, we can put in a lens. And now, once you put in a lens, you can focus light, right? And as we have seen, lens follows a lens equation, right? That is 1 over u, where u is the object distance from the lens. And recall the sign convention: anything that is to the left is negative, anything that is to the right is positive. Is 1 over f, right? So now once you place a lens, your image naturally becomes brighter and sharper. Why? Because the lens is able to focus all these rays, right, properly, right? That's the action of the lens. But it becomes a little tricky with the lens, because now your object distance is fixed. In case of a pinhole camera, there was no equation. There was no 1 over u plus 1 over v equal to 1 over f. So then, if I want the image to form on the film, right, then I must have my image 1 over v should be such that 1 over f, where f is the focal length, minus 1 over u, right? So this distance between the lens and the screen or the film is limited once you use a lens, because lens follows a certain equation. It is mainly limited by the focal length of the lens. So if I were to, for example, bring this object very close, right, uh, I may not be able to capture it completely. Or if I take it too far away, it's still the same thing. I may not be able to capture it properly because I'm changing u and keeping the f constant. So my image distance would change, and that image distance need not be same as this distance here, right? So your image can get blurred. So you can do this very easily. Your eye has a lens, right? So you know, be make sure that you don't get a headache. Okay. So you close one of your eyes and you bring a finger close to the eye and then take it farther, and then you will see that it comes into focus at one particular point, right? So essentially what you're doing is this: you're adjusting the object distance. The focal length is pretty much fixed. It can vary a little in the eye, but it's fixed compared to the object distance, and by varying it you're able to see the finger becoming sharper or not sharper, right? So that's the advantage of having lens. So we can make cameras where the lens can be taken out and a different lens can be inserted. For example, as you know, if I want to choose, say, some close-ups, I can have a wide angle lens, right? A wide angle lens would capture a lot of light. It has a short focal length, and because it has a short focal length, uh, so let me write the equation here again. 1 over v is equal to 1 over f minus 1 over u, right? So if both u and v are short, then they can match up with f, right? So you can use a wide angle lens that has a short focal length to get close-up objects, and similarly you can do distant objects with a telephoto lens that has a much longer